Good afternoon. Today I'm going to do the revision lessons. In the last, I will share them on the screen here. You can see. I think you remember the last lecture we did about the modern physics part. In the modern physics part, we study some theories, right? These are the questions 1 to 5 based on the last lecture, modern physics lecture. In the first one, you can see, I think you remember, determine the frequency F and wavelength lambda of a photon with an energy of 3.31 10 minus 19. Then here, this is based on the modern physics. Frequency and wavelength. Other thing is energy. Then I think you have to remember that what is the equation behind in this question. The frequency F and wavelength lambda per photon with an energy is given, then we have to find the frequency of the particle. Then energy equation is, I think you remember, E is equal Hf is our equation, and using this equation we can find the frequency of the particle, and lambda and F, what is the equation behind this, right? We will see. I will share my board and I will right. Then you can see my whiteboard. Photon has an energy is given, and we have to determine the frequency. One lambda. Energy equation is in the E is equal Hf. H is the Planck constant. In the calculation, in the question paper, we are mentioned what is the Planck constant, right? Then H is the Planck constant. Then we can find value of H is equal 6.626 into 10 minus 34 joule second. Planck constant. Then we can find F in the previous equation, E over H is equal to the frequency. And this is equal 3.31. 10 minus 19 is the energy, and 6.626 into 10 minus 34 joule per second. Then you can find what is the frequency of the particle. 4.99. 5 into 1014 measured by H is the Planck constant. Using the Planck's theory, then we can find frequency of the particle, right? Then question is asking about the lambda. Then what is the relationship between the F and lambda? Frequency and lambda. Then we can see C is equal F lambda. What is the C? C is the velocity of light. And F is the frequency. And lambda, wavelength. Right? Now we know about the F, frequency of the particle, then you can find lambda there. Lambda is equal C over F. What is the value for C? The velocity of light. It is also mentioned in the question paper. And then 8, and you can divide by F. We found the F, right? And lambda is equal 6.006 into 10 minus 7 meter. Right? Then very easy questions. This related to the modern physics parts, right? And, Planck constant, Planck's theory, and E is equal Hf, and second equation C is equal F lambda. And you can find value for the F and also lambda. Right. In the second question, first I finished about the modern physics questions, then I move to the other part, right? This is the question. The temperature of human skin is 35 Celsius. Determine the wavelength at which the emitted thermal radiation reaches maximum intensity. In this question, theory is behind. What is? The temperature of human skin is given 35 Celsius. Then we have to determine the wavelength which emitted thermal radiation reaches the maximum intensity. I think you remember we study about one theory at the lambda, maximum intensity. And the maximum intensity asking about the wavelength. We call this as the lambda max. Right? I work out it. Share my board. Right. This is the maximum intensity. At the maximum intensity here. Field value of the graph. Right? And lambda max. I think you remember that. What is the theory behind this? Black body radiation. Black body radiation is the behind the theory with these questions. And Wein's displacement law. Last day we discussed about the Wein's displacement law. Can be lambda max. T is constant. This is called as the Wein's law. Wein's constant. In the question paper, we are mentioned about Wein's constant. This is the Wien constant, right? Then you no need to remember that. You have to remember the equation only. The lambda max T is equal B. B is the Wien's constant, right? And what is the T? T is the temperature. But you should remember we are substitute the value for the temperature. This is capital T. It is measured by Kelvin because this has the absolute temperature or Kelvin temperature. Absolute temperature. If not, we got this as the Kelvin temperature, right? Then we can find Kelvin temperature. The temperature is given by 35 Celsius. Then we can add 273. Then we can convert this into Kelvin, right? Then we have to substitute the value for the temperature in Kelvin temperature, right? Then how we convert Celsius to Kelvin? We can add 2273 for the value. Then T can be found there, right? It is equal 308 Kelvin, right? Then lambda max T, B is Wien's constant. It is mentioned, it is given. This is the given data, right? It is equal to 2.9, 10 minus 3. MK is the unit, meter and Kelvin, right? Then we can find maximum lambda value using the Wien's displacement law. Very easy. Then you have to remember the equations only, right? The lambda max is equal B over T. And we consider the units also 2.9 into 10 minus 3 meter Kelvin, right? Then we should substitute value for capital T by Kelvin temperature. Then Kelvin cancel out. Lambda max. Maximum lambda unit is meter, right? Unit is meter. This is equal 9.5 into 10.6 meter. Right? Then you can calculate in home. Then answer is 9.5, 10 minus 6. Or if you want, write this 9.5 micrometer. The micrometer. Answer is micrometer. Right. We will see the next section. Then you can work out this. Right? Write down this. Then lambda max T is equal B. Then you should remember the equation behind this black body radiation. Right? Then we will see the next question. Theory. First I discuss about the modern physics questions, right? Then what is the next one? You can follow up these things, right? Then work function is given. Work function is given. What is the threshold wavelength of the metal whose work function is 6.63 electron volts? And here, sorry, question number 3. What is the threshold wavelength of a metal whose work function is given as 6.63 electron volt? And in your reading the question, you should remember what is the theory. The threshold wavelength and work function. These two words coming in photoelectric effect, right? When we studied last day about the wave nature and particle nature of a particle, right? The particle can, sometimes it is acts as the particle and sometimes it acts as the wave, right? We call this two duality, wave particle duality, right? Then the question number 3, what is the threshold wavelength of a metal work function is given. Then when the word is threshold wavelength and work function, then you should remember what is the word behind this. This is the based on the photoelectric effect. I think you remember the electrons and photons are coming and then electrons, free electrons are emitted by metal surface due to the photon radiation, right? So the frequency and psi work function is given by psi. Photoelectric effect theory is behind this question. Then phi is equal 6.63 electron volt. First thing is you should convert this into joules. Phi is 6.63 electron volt, and in the question paper I mentioned 1 electron volt is equal how many joules, right? 1.60 to 10 minus 19 joules. Then we are given data. This is the given data. It is mentioned 1 electron volt is equal 1.60 to 10 minus 19 joule. Then first, then phi work function is based on the energy. Then we can convert it into 19 joule. I am converting it into joule, right? Then this is equal 1.06 into 10 minus 18 joule. First, you have to convert this. This is important, right? Then other one. The question is asking lambda and phi. Then you have to remember the equation of the wave function is equal hc over lambda naught. Hc over lambda naught. The equation behind it. Then lambda naught, we can find hc over phi. Then what is the h? H is the Planck constant. And c is the velocity of light. And phi is the work function. Then we calculate value of work function by joule. then we can substitute the equation. 6.626 into 10 minus 34. As I said before, they are giving what is the Planck constant value, right? And c is the velocity of light, and phi, we convert it into joule, 10 minus 18 joule, then you can find lambda not wavelength value related with this work function, right? Then you can calculate this and check with my answer, 10 minus 12 meter. Lambda is equal 73.13, 10 minus 12 meter, right? Then here, photoelectric effect, you should remember 5. Unit should be convert to joule, and other one is what is the equation behind with work function and lambda related equation, work function and lambda you have to remember, right? Then this is the photoelectric effect. Last day we discussed about in physics 1, right? In the next question we will see right. Question number 4. Calculate the de Broglie wavelength of electron moving at 6.6 into 10 5. The velocity is given and also mention that de Broglie wavelength, right? So what is the de Broglie wavelength? Then you have to remember the equation around the de Broglie wavelength. De Broglie wavelength lambda. I think you remember lambda is associated with momentum and p, right? P is the Planck constant, the momentum, and p, lambda is associated with, right? Equation behind this, calculate the de Broglie wavelength of the electron moving at velocity is given ms minus 1. And we know mass of the electron, it is also mentioned in the question paper, right? These data are given, right? You are given. Then h is equal, lambda is equal h over p. This is the de Broglie wavelength. Then you should remember. Lambda is equal h over p. Right? H is Planck constant. What is the p? P is the momentum. Then we can find the wavelength associated with momentum using the de Broglie wavelength, right? Then here, but mention that about the electron. Electron is moving at. What is the velocity? Velocity is mentioned as 6.60 into 10 5 ms minus 1 meter per second. This is the velocity of the electron, right? You can see in the equation directly P, mentioned that P, the wavelength associated with the momentum is lambda is equal h over P. But in the given values, they mention about the velocity. Then we have to substitute value for P, right? P. Then we know the P, momentum. Momentum is related with mass in velocity. Mass into velocity, right? Then electron is considered, then we have to know the electron's mass and we can multiply it by velocity, right? The mass is electron. This is also given in the question paper. I will give the value. Then on you to remember 9.11, 10 minus 31 kilogram. It's the mass of the electron, right? The electron mass and velocity is given. Here, we can multiply this by 60 into 10 5 ms minus 1. This is the P, momentum of the particle, right? Momentum of the particle. The value is 6.0126 into 10 minus 25 kg ms minus 1. This is the momentum related to the electron mass and multiplied by velocity. The electron momentum we can calculate, right? Question is, what is the de Broglie wavelength associated with this electron? Then we can substitute value for momentum, right? This value we can substitute the P and Planck constant already we know 6.626 into 10 minus 34. Then can find de Broglie wavelength, right? And you should remember these points. Equation and what are these representing? Momentum and Planck constant. If they are giving velocity, then how to find the momentum? Then we should know aware about these things, right? Then after that, we can substitute for momentum. Lambda is equal h over p. H value is Planck constant 6.626 into 10 minus 34. 10 minus 34 joule per second. Right, then lambda is equal, then you can calculate and check with my answer. What is the answer? 1.10, 10 minus 9 meter. 10 minus 9 meter. Then we can convert it into nanometer, 1.10 nanometers. 10 minus 9 means the standard value, 10 minus 9 meter, then we can convert it into nanometers, right? Then step by step, I'm giving marks, so you can follow up very easy. Thing is, you have to memorize the equations and things, right? Then momentum, we have to convert it to momentum with using the given values, right? The other one, other theory, last day we discussed, because I think you remember the theories. That's why I start from last day theories, right? The other questions, last question. In the modern physics one, an electron has position uncertainty 1 angstrom, right? Determine the minimum uncertainty in its momentum. Calculate the minimum uncertainty in the momentum of the electron. If its position is given as uncertainty 1 angstrom, right? Then I think you remember uncertainty. The theory is behind it, this word, position uncertainty, right? Then what is the uncertainty in the momentum? I think you remember Heisenberg uncertainty principle. It is said to be, let's say to that, position and momentum. We are measured simultaneously. Simultaneous means on one time, right? The same time we measure momentum and the position. But this can be error. This can be precisions, right? There can be an error. So the error is equal. The error is equal, then I think you remember about taking momentum error. Momentum error, position error. We are measure position and momentum. momentum and position simultaneously. Simultaneous means at same time. Same time I'm measuring X and P. Right? Then the error can be happen. Uncertainty can be happen. Then delta P is the uncertainty of the momentum. Then another one is delta X. Delta X is uncertainty of the position or error or precisions, right? Then what is the relationship between these two uncertainty? Delta X and delta P, right? It is expressed as the Heisenberg uncertainty principle. Then this is equal delta P and delta X. Multiplication of this uncertainty, it is greater than equal H cross over 2. What is this? This is represent Heisenberg uncertainty principle. Heisenberg uncertainty principle is right. Then we can convert this H cross is equal H over 2 phi. It is also related with the Planck constant, right? Planck constant divided by 2 pi is the H cross value, right? Then we can substitute. Then the question is asking about the momentum, right? Then greater than equal at the minimum value is equal sign, right? H over 2 phi. Then equation can take delta P delta X greater than equal H over 4 phi. This is the uncertainty principle. Then you should remember the equation and also relationship behind H cross. It is equal H over 2 phi, right? Then you can substitute the value. Delta X is given, right? Delta X is 1 angstrom. Delta X is equal 1 angstrom. We have to convert this into the standard units. Delta X is equal 1 angstrom means it is equal 1 into 10 minus 10 meter. 1 into 10 minus 10 meter. Then we can follow up delta P. Delta X greater than equal H. H is the Planck constant. 6.626 10 minus 34 negative 34 divided by 245 divided by 45, right? Then you can find out at the minimum point we can take the equal sign. Then delta P greater than equal 6.626 into 10 minus 34 divided by 45 into delta X. It is equal 1 into 10 minus 10. Then delta P is equal at the minimum point. Then we can calculate this 5.28 into 1025 kg ms minus 1. This is the answer, right? Then very easy. You have only remember the equation, precisions of momentum and precision of position. Precision of error of the delta P and error of the delta X, then you can remember, right? Delta P is equal to this value and other one is delta X, delta P into delta X greater than or equal H cross over 2. This is H cross we can replace by H over 2 phi. These are the things you have to remember about the Heisenberg uncertainty principle, right? The basic ideas about the modern physics part. wave particle duality and what is the behind things in uh, particle nature and wave nature can identify using the black body radiation and Heisenberg uncertainty principle photoelectric effect. These are the we can understand about. Let me
Yes, madam.
I finished that part, then I discuss some questions related with the modern physics part, right?
Ma-
Then you can follow the
okay, madam. I
recordings.
will refer the recording. Yes, madam.
Uh, only five questions I discussed, right? Related the
Okay,
uh,
madam.
modern physics part, right?
Okay, madam.
Okay, the five. Then I'm going to other part. Then today I'm doing the revision. Temperature,
Okay,
heat,
madam.
and thermodynamics. Temperature, heat, and thermodynamics. The theories we have done in the class. Then I want to remember these things. Then heat capacity and specific heat. The specific heat capacity we may denoted by simple C. And what is the heat capacity? Then water and taking the glass, drinking glass is much smaller than, then we can get the idea about the heat capacity thing, right? Then the heat capacity of the system is proportional to the mass of the system. The specific heat capacity, the symbol is simple C of a substance is defined as the heat capacity per unit mass. So then we can find the required heat for increasing temperature of the system is Q mc delta T. This is the equation, right? In the mc delta T, so the required heat to increase in temperature of a mass and by temperature delta T. When Q is equal mc delta T, C is represent specific heat capacity. And other one you should remember about the phase transition. Phase transition occurs whenever material is changed from one phase, such as the solid phase, to another, such as the liquid phase. In this diagram, we can understand in the during two-phase transition. One is melting, you can see, another one is boiling. So we are added heat, but during the phase transition, we cannot see temperature increases. Temperature increases of the mixture, then we cannot see the temperature of the mixture of two phases does not change. During this time, then ice and water here, then we can see all ice are melting. All ice are melting. Uh, convert all ice phase transition is convert to the water at this melting point. Then other one, then we can again heat up the water and at the point Celsius 100. We know this is the boiling point of the water. At that point, we are adding heat. We are supplying heat, but we cannot see increase of temperature. Any increases of temperature we cannot see at the boiling point, right? Boiling point, we cannot see the phase transition. The thing is, you should remember during the phase transitions, the temperature of the mixture of two phases does not change. At that point, we call as the latent heat. Latent heat, hidden heat applied. Right? Then what is the definition of the latent heat? We denoted is by capital L. The heat required per unit mass of substance to produce a phase change is called latent heat, capital L. The word latent is related to the lack of temperature change during the phase transition. It's called this as the latent heat, right? The heat per unit mass for the solid liquid phase transition is called the latent heat of fusion, LF. And also other directions can happen. Liquid can change to the solid, latent heat is appearing. For the liquid gas phase transition or in either directions, means gas to liquid, the heat per unit mass is called latent heat of vaporization, right? The questions can find, then sometimes questions are giving, find the heat required for this process, then equation can take you E is equal mc delta T, and other than during the phase transition, heat is equal mA, right? This can be happen. The question is behind it. I give one question. How much heat has to be transferred out of 1 kilogram water vapor if it is initially at 150 Celsius, cools to 100 Celsius, and again cools further? The fusion is happening. This is fuses into ice at 0 Celsius. Right? In this question, all things are behind. Increases of temperature, then mc delta T also added, and ml, latent heat also inside this one, right? Then how can we solve this question? Sorry. Then we can transfer out 1 kilogram of water vapor. Initially as 150 Celsius, then first we have to convert, then we have to find out the energy required for cooling 150 to 100 volt. Then again cools further, then at the Celsius 0, then it is become freezing as an ice, right? Then we can cover, we can find total heat required. Total heat required. It's step by step. We can find out it. Right. Then they should given, then in the question, then we are measuring what is the C, specific heat capacity of water, and specific heat capacity of steam, and latent heat of the fusion, and latent heat of the vaporization. We should mention that, right? The total heat required we can find in 4 stages. Total heat removed in 4 stages. And then one by one can mention. One is cooling steam from 150 Celsius to 100 Celsius. This is the first step, right? Then we can find the energy required for this process in 150 to 100 Celsius. In the question, you can understand there is a temperature change. There is a temperature change. Then we can find Q1. If there is the temperature changes, then you can remember the equation mc delta T. mc delta T. Required energy, remote energy, right? What is the C? The steam. Cooling steam to water. CV is specific heat capacity of steam. Then they will give. The question paper, it is mentioned 1.89 in 10.3. Right? Specific heat capacity of steam. They will mention that. And given data, then you can find what is the MC delta T. Then we can substitute. M is 1 kilogram of water. 1 kilogram of water. Then M is 1 kilogram into 1.89 into 10.3. And delta T. That is change in temperature. It can be substituted by Kelvin or Celsius. Both are correct. Because then we are taking temperature changes 150 Celsius minus 100 Celsius. When we are converting this 150 Celsius, we should add 273 and minus by 100 plus 273. Then 273 is common value. It will cancel out. So then we can substitute by Celsius or Kelvin. Same. Temperature difference is same. Right? Then no need to convert to Kelvin because it is also Kelvin value is same. The temperature difference is 550 Kelvin. Then you can find Q1 value required. The remote in 4 stages, cooling steam from 150 to 100 Celsius. This is equal 9 to 4,500 Joule. This is our first step, right? And the second one, the steam is cooling to water at 100 Celsius. Then at this 100 Celsius, steam is cooling to water. Then what is happening here? Right? Condensation is happening. Condensing steam to water at 100 Celsius. Right? Condensing steam to water at 100 Celsius. Then this is happening. Then you can see water, steam change to water at 100 Celsius. So there is no any temperature difference. Then what is happening? 100 Celsius steam convert to water. It is also in 100 Celsius. Then you can understand there is no any delta T. There is no any temperature. Then what is the equation behind this? This latent heat. Latent heat. No any increases, no any decreases. We cannot see in this transition. Phase transition is happening. Steam to water. Steam to water. Right? Steam to water happening. Then we can find Q2. Q2. The required remote energy. Q2 is equal ML. ML. We call here MLV. Latent heat in vaporization. Latent heat in vaporization is MLV. Right? Mass is not changing. We consider 1 kilogram of steam. Right? LV. Then latent heat of vaporization also given. This is equal 2.26 into 10.6. They will mention. They will mention this is the value for the latent heat, right? After the questions, within bracket, they are giving the data. But the specific heat capacity of the steam and latent heat of the vaporization should be given, right? Then we can substitute this value in our equation. M is 1 kilogram into 2.26 10.6. Now, the energy required, energy removed in this process into 10.6 kilogram because energy removed in 4 states, then what happening? 150 steam convert to 0 ice. This is the process. Then energy is removed, right? 2.26 into 10.6 joule, right? Now, water is at 100 Celsius. Then we have to convert in water into 0 water, right? And other one is, then we have to take cooling water from 100 Celsius, 100 Celsius to 0 Celsius, right? In this process, you can see 100 Celsius to 0 Celsius. Temperature change and also one phase is here, water, only water. Water is changing its temperature 100 to 0. So you can remember there is a delta T. There is a delta T, then Q3 can be found using MC delta T. The equation MC delta T. Then what is the C? C is the specific heat capacity of water. Because water, only water, we can see that C is specific heat capacity of water. It will be given, then value is 4,190. Normally we are taking as 4,200. If they are mentioned 4,190, then we can take this value. Then we can substitute for value. Mass is 1 kilo and C is 4,190 and delta T 100 Celsius to 0 Celsius. Temperature change is 100. Temperature is changing by 100. Right? Then we can multiply this by 100 Celsius. Right? Then answer is coming in the cooling water from 100 Celsius to 0 Celsius. It is equal 41,900 joule. Right? Then we found the third step. Then what is the last step? Then freezing water to ice. Then water is now in 0 Celsius. We starting steam from 150 Celsius. Now it is converted to 100 steam. Then steam is condensation to water at 100. And again water convert to 100 water Celsius. 100 water to 0 water. Now then we convert, we freeze it 0 water to 0 ice. Right? This is the last step. The last step is freezing water. Water is freezing in 100 solid, right? Freezing water. Freezing water to ice at 0 Celsius. Now you can see water is converted to ice. Phase transition at 0 Celsius. At 0 Celsius. Now water is in 0 Celsius and it converted to 0 ice, right? 0 ice. Then latent heat is appear. Latent heat is appear, right? Then we can find Q4 is equal MLF. MLF, what is the LF? Latent heat of fusion. Latent heat of fusion. Then value will give, mass is not changing. It is 1 kilogram, 3.34 into 10^5. Then you can calculate 33,400 joule. This is the last one, right? This is the last one, Q4. Q4 value can be found. Freezing water to ice at 0 Celsius. Phase changing you can see, but temperature is not changing. So you should remember latent heat is applicable here. Latent heat is applicable MLF, right? Then we can found the step by step we found all energies related to this question, right? Then total energy. Then energy is removed because then its steam is converted to ice. Then energy is removed, right? Then total heat can found by adding all energies. Q is equal Q1 plus Q2 plus Q3 plus Q4. Then you can add all its steps, all energy can add, right? And Q is equal after calculating. Then you can check with my answer 3.1075 into 10 6 Joule. Or this can be written as 3.1075 megajoule. Right? This is also correct. The energy in 1 unit, the megajoule is the unit, right? This is the theory behind the phase transitions and specific heat capacity. Right. And other thing is, then in the heat and temperature, we covered this part also. About thermal conduction. Thermal conduction. Then questions can come related with to the thermal conductions. The conduction of heat can take place within solid, liquids, and gases. The conduction is due to the collisions between atoms or molecules in which energy is exchanged. The conduction also occurs between objects that are in contact, right? That are in contact. Then what is the equation behind in here? P equal Ka times delta T over T. Ka times delta T over T, right? And what is the P? P is telling that Q over T. It is represent the rate of heat flow or power. Q over delta T within the 1 second, within the unit time, how many heat flowing in this process? It is caused by Q over T. Then K is the thermal conductivity. In the questions, thermal conductivity will be U of the materials. A is mentioned that cross-sectional area and D is the thickness or length of the material. And delta T is the temperature difference. Temperature changes between one side to another. Right? Then thermal conductivity equation is equal then P Q by delta T is equal Ka times delta T over D. D is the thickness. So sometimes we can take as the length. Right? And delta T over T is called as the temperature gradient. Temperature gradient. Right? Then we will discuss one question related to the thermal conductivity. I will put questions in my board. Then you have answered, and I think the final question paper only 60 marks, right? Then if I'm giving 3 questions, then you have to answer. One question is 20 marks. If I'm giving 4 questions, this I think, yes, 60 marks or 40, I remember. But I'm giving 3 questions. Then out of 5 questions, you have to answer about the 3 questions, right? I will check. the question paper consists of 60 marks. Then if we are giving three questions, one is 20 marks. If you are giving two questions, belongs to 30 marks. Then I am giving three questions, 20 marks, three questions out of four. Then you have to answer three questions, right? 20 marks is here. Then you can remove one questions. Right. Then other one is the thermal conductivity. The thermal conductivity, then we know the equation Q over T is equal Ka times delta T over L. L is the length or thickness. Can write that. Then I will discuss the questions. I will put one question in the board. The sheet of metal 1 taking this as metal 1 is placed in thermal contact with another sheet. Then we can call this as in another sheet of different metal. Right? It is metal 2. We can take it as metal 2. The two sheets have the same area. The same area and are joined. They are joined, right? Are joined so that heat transfer freely between them as shown in the diagram below. Right? Then diagram is given in the metal 1 and metal 2. And thing is, the sheet of metal 1 is placed in the thermal contact with another sheet of different metal. The two sheets have the same area and are joined so that heat transfer freely between them as shown in the figure. The diagram is given like this. The metal 1. Another one is metal 2. Right? The diagram is here. Dimension capital T. Capital T. And temperature mentioned that 50 Celsius in this side, another side 150 Celsius. 150 Celsius. The thermal conductivity, the thermal conductivity thermal conductivity of metal 1 is twice the thermal conductivity of metal 2. And the thickness and the thickness of metal 1, metal 2, sorry, metal 2 is twice. Then twice the thickness of metal 1. Thickness of metal 1. If the temperature, if the temperature of metal 1 is fixed, then you can see also in the diagram fixed at 150 Celsius. And on the outside of the metal 2, outside of the metal 2, is fixed at 50 Celsius. What is the temperature? What is the temperature at the plane? At the plane where they are joined. Where they are joined. In Celsius. Question is asking in Celsius, right? Metal 1 and metal 2, they are joining at that point T, and temperature between then 150 Celsius and other hand 50 Celsius. The details are given, the metal 1 and metal 2. The thermal conductivity of metal 1 is twice the thermal conductivity of metal 2. And the thickness of metal 2 is twice the thickness of metal 1. And if the temperature of metal 1 is fixed at 150 Celsius, and other hand is fixed at 50 Celsius. Question is asking about T. Very easy. We know the temperature, heat is flowing continuously, and in the thermal conductivity equation we know Q over T is equal Ka times delta T over L. This is the equation, right? In the given data, we will find what's thickness and length of the two metals. metal 1 and 2. On 50 Celsius, on 50 Celsius, we have to find capital T in Celsius at the point, right? Celsius, so Kelvin is so, right? Then we can say, then given data, thermal conductivity of metal 2, we can take as the K. Thermal conductivity of metal 2. K. I'm taking thermal conductivity. K is the symbol for the thermal conductivity. The thermal conductivity of metal 2 taken as the K. Then in the given data, then thermal conductivity of metal 1 twice than the metal 2, right? Then we can find out thermal conductivity should be equal in metal 1 to K times. It is mentioned that thermal conductivity is twice than the metal 1, right? Metal 1. The 1 is the thickness. Then I'm taking thickness of metal 1. Thickness means this side, right? Thickness of metal 1, if it is equal x, according to the data, thickness of metal 2, this should be equal 2 times x. 2 times x. Now, the joint temperature is capital T. Since heat flows steady through both metals, right? The rate of heat transfer should be the same. Then we can write since heat flows steady through both metals. Both metals. The rate of heat transfer should be same. The rate of heat transfer is the same. Now we can substitute the equation, conductivity equation, right? Conduction equation, Q by T, this is the equation. Q over T is equal Ka times delta T by L. Now you should remember the equation, the conductivity equation you have to remember, right? Ka delta T times L, that's steady flowing. Heat flowing is steady through the both metals. So then we can write the common equation for metal 1 should be equal metal 2. Heat flowing rate, metal 1 should be equal metal 2, right? And in the metal 1, what is the K? 2K. And cross section area is same. Then you can see the cross area is same. They are joining to each other. Cross area is same. And what is the metal 1? Temperature changes 150 minus T. Divided by thickness is x. Thickness of the metal 1 is x. Then this should be equal because the steady flowing through the both metals, this should be equal in metal 2. In the metal 2, thermal conductivity equal K, cross area is same, and delta T. Then temperature is T, now 50 Celsius. Then T minus 50 divided by thickness. Thickness of the metal 2, then you can see this is greater value. It is equal to x. 2x. But the equation is like this. Then we can equal heat flowing equation. Then can find what is the temperature T. Solving this equation, then x is cancelled out, right? Then Ka also cancel out, right? 2 times 150 minus t. Minus t equal in the other hand 2 minus 50. T minus 50 divide by 2. Then can cross multiplication, this become 4. Then 600 minus 40 equal t minus 50. Then 5t is equal 650. Then t is equal 130. It can be Celsius or Kelvin because delta T, then Celsius. Now we put here the Celsius value. The answer is coming the Celsius, 130 Celsius, right? Then question can come in the thermal conductivity of this. Okay, then T is what we can find 130 Celsius. Then you should remember conductivity equation. Conductivity equation you have to remember. Right. The next part in electricity one, right? Before moving that, I'll share our electricity note. Then I want to. Yeah. Let's see. Electricity one. Want to take the electric field and electric potential, right? I think you remember the Coulomb's law. Coulomb's law is coming. Attraction or repulsion force between 2 point charges Q1 and Q2. Electrostatic force we can find using the Coulomb's law. K, Q1, Q2 over R square. If they are giving charges, then point charges, it's Q1 and Q2, then you can find a value for the F force between them. It's the one thing we learned on the previous days, right? Other one is, I think you remember, electric field intensity. Electric field intensity is equal F equal Q naught E. If there is a point charge Q naught is placed in the electric field, the force can be found using the equation F is equal Q naught E. Right? F is equal Q naught E. And the electric field intensity using the Coulomb's law. Also we can write this is the vector notation. If not the vector notation, we can find K times Q over R square. Direction can be decided by attraction or repulsion force. Right? Then other one is in the electric field. We can find the electric field direction. If the particle is starting by point plus 1, a positive value, the electric field lines go from the positive to negative terminal. It is terminal at the negative charge. But then when they are given a positive electric charge, then we know the electric field, direction of the electric field is outside the positive electron, right? Like this. Then you should remember because sometimes the calculation, then question calculation, direction is important. The direction of the electric field is starting from positive charge and negative terminal by the negative charge. Then other one is These are the things. Then principle of superposition means then we can find electric field. If there are so many charges, individual, the sum of the electric field of all the charges is equal to the total electric field. Then you can see Q1, Q2 and Q3. If they are same charges, we know electric field intensity. Electric field should be equal. Right? And here pink color arrow represent the total electric field. Right? Then thing
Miss, we
is you have
cannot see the slide yet.
cannot see.
No.
I shared. Okay, I will share again. Sorry. Now can you see?
Yes, now can see.
Okay, sorry. Then these are the equations you have to remember. F equal Q naught E. Another one is E can be found in the point charge. 1 over 450 naught we are representing by K. K times Q over R3 lines, right? Then force lines, starting from positive charge and terminal by negative charge. Then these are the force lines. Then other one is principle of superposition. I told here. Then we can find resultant electric field. Resultant electric field can be found. The vector sum of individual electric field is equal resultant electric field, right? Before move to the electric potential, I have discussed two questions related with electric field intensity. Wait, I will share two questions. Still not sharing, right? Please wait. Can you see the different slide? Can?
Yes, madam, can see.
Okay, then the one question I want to discuss about the electric field. Right. Then this question. Again, go back. No? What happened? Right. This question. Try to do this one related with the electric field. Another question I will give next after that. Q1 and Q2, capital Q1 and Q2 is minus Q. Then here you can aware about the direction because one is negative charge, other one is positive charge, right? Then Q1 and Q2 each experience an attractive force of F when they are placed distance r apart. if a charge Q3 is equal to Q is placed halfway between Q1 and Q2, then what is the magnitude of the total force Q3 will experience? Now Q3 is placed in between halfway of the Q1 and Q2. Right? Then we will see. And in terms of F, you have to find the value by F. Q1 and Q2 minus Q, then they are distance apart from R. And Q3 charge is placed, then asking question, what is the magnitude of total Q3, right? I will share my board. Discuss the question. This is related with the electric field. Capital Q1, I mentioned details here, is equal 9. Sorry, Q. And Q2, it is equal minus Q. And Q3, next time we are putting 2Q between these two, right? Then in the first, they are putting Q1 and Q2 like this. And Q2, separation is R. Then Q3 is placed halfway between them. And it is distance from each charge is R over 2. Right? Then we are keeping our Q3 charge halfway of this. So, distance between Q3 and Q1 is R by 2. Then original force we can find. The original force between Q1 and Q3. Sorry, between Q1 and Q2. This is equal F. Right? This is equal F. They are giving as F. Then we can write F is equal in our equation K Q squared over R squared. Q1, Q2. Then between the force Q1, Q2, Q1 and Q2, this is the attraction force. Right? Then we can write F as K Q2 over R squared. The original force, right? Then now Q2 is put here, Q, positive Q, and Q2, negative Q. Now we are putting Q3 charge between these two, then R by 2, the particles, then R by 2. Distance between these two are R by 2. What is the value for Q3? Q3 is positive charge plus 2Q times, right? 2 times of Q. 2Q charge in positive charge. Then what happened? When we are considering Q3 charge, you can see 2 charges effecting for the Q3, right? The resultant force we have to find. Then one is force Q1 and Q3. Other force is Q3 and Q2. Then between Q3 and Q2, there is a force. And Q1 and Q3, there is a force, right? Then we can find force by Q1 and Q3. Then we can write the Coulomb's law between the force Q1 and Q3. I'm taking it as F13. F13 is K, what is the Q1, Q, and Q3 is 2Q divided by R by 2 square. Because Q3 is in the midway of the line, right? Then answer is coming by K 2Q squared divided by R squared over 8. Sorry, 4. R by 2 squared. Then answer is coming as 8K Q squared divided by R squared. The question is asking the terms of F. Then we can write F13. Then comparing with this, KQ of R squared is F. Then I can replace KQ squared over R squared by F. This is equal 8F. The choice between Q1 and Q3. Q1 and Q3. Then there is the repulsion force because this is positive charge and also positive charge. Then this is the repulsion force F13. The direction is this, right? F13 is repulsion force. It is equal 8F. Then what happened the next one? The Q3 and Q2. There is the minus Q charge. The force acting on Q3 and Q2 also. So we can find what is the force due to Q3 and Q2. Force by Q2 and Q3. Force by Q2 and Q3. Then we can write F23. It is equal Fk times Q1, Q2. Q is Q. Another one 2Q divided by R by 2 square. Now direction. What's the direction? This is charge is positive and this is negative. We know between these two there is an attraction force. The direction of the force is left hand side. F13 also left. F23 is also left hand side. F23. Right? Then value is, we can find value. This is also equal 8K Q squared divided by R squared. So again we can write, we know KQ squared are the original force between Q1 and Q2. This is also equal 8F, right? 8F. Then we can consider two forces, direction of two forces, and we can see what happened, right? In the Q1 and Q3 is here, and Q1 and Q2, right? The force between Q1 and Q2, Q3 is the repulsion force. Line is 8F. And other particles, Q3 and Q2, also 8F, but it is attraction force. It is also in the same direction. So we can write, also have same magnitude and the same directions. Q1 repulse Q3, but Q2 attracts Q3 with same direction and same charges. Then total force acting on Q3 is equal 16F. 16F. This is the answer, right? 16F. Then we can find total force acting on Q3, right? Then I'm giving another question. You can write down it. Related with the electric field intensity. Two positive point charges Q1 is equal positive 16 microcoulomb. You should be aware about the units also, right? Microcoulomb. And Q2, this is equal positive 4 microcoulomb also. Are separated in a vacuum. In a vacuum by a distance 3 meter. Find the pot on the line. On the line between the charges. Between the charges where the net electric field is 0. Net electric field is 0. Net electric field is 0. The positive point charges, one is 16 microcoulomb and other one is 4 microcoulomb. It is separated in a vacuum by distance is given as 3 meter. Find the spot on the line. In the line, there is a position. The electric field can be 0. Then ask the question, what is the position? The electric field is 0. Right? Then we have to understand about the electric field intensity. What is the definition? The definition is we can put 1 point charges, 1 coulomb charges in the electric field. The force acting on 1 coulomb charge is we call as the electric field, right? And also we know the electric field can be taking the vector sum of the electric field. It is can be take, right? The vector sum. Then now the net electric field is 0 means there is one position. In the electric field balance from each other. Balance out with each other. Then we will draw the line and I'm taking here plus Q1 and the other end plus Q2. Right? The point charges are given Q1 and Q2. After that, we can substitute value. So I am taking positive Q1 and positive Q2. Right? Then there is the line can sometimes between these two and outside the Q2 or outside the Q1. Our point can be happen. The electric field intensity is 0 at that point. Right? Then I am taking, this is the point P. This is the point P. Electric field intensity is 0. I assume at point P, electric field intensity is 0. At the point P, electric field intensity is 0. Then take in the distance. Q1 to P is D. Right? Then we know distance between Q1 Q2 is 3. So P to Q2, this is 3 minus D. 3 minus D, right? If they are in force, then Q1, we can put the point charge here, positive charge here. Then, if this is the positive charge, the repulsion force is happening as E1. And also Q2, due to the Q2, force can happening as E2. If the electric Let me, can you see my, can you hear me?
Yeah, madam, I can hear you.
The electric, then Wi-Fi dropped.
Okay, madam. Okay, now only can see the screen.
Okay.
Okay, madam.
Then at point P, electric field intensity is 0 means then force acting on E1 should be equal E2, right? This is our theory. Then at point P, E1 should be equal E1. E2. Electric field intensity is 0 means this should be E, right? Then we can find in our equation electric field intensity. We are putting 1 Coulomb point charge at the point. Then electric field can define E is equal KQ over R squared. The equation KQ over R squared, distance between two charges. So E1 and E2 should be equal. Then we can write the equation due to the Q1, electric field is E1. Then E1 is K times, what is the Q1? Charge is 16 into 10 minus 6 divided by R. R is distance D, V squared. And this should be equal E2. E2 is K times 4 into 10 minus 6 divided by 3 minus D squared. It's the electric field intensity equation. Right? Then electric field intensity should be equal at that point. The electric field intensity 0 means E1 should be equal E2. Now we can calculate the D value, right? K also cancel out. 10 minus 16 cancel out. And 4, here 4. Then 4 times 3 minus D squared should be equal D squared. This is the quadratic equation. So we can take 4 times 9 minus 6D plus D squared equal, on the other hand, D squared. Now we can solve the equation. This is the quadratic equation. Then there are two values for D. There are two values for D. Then can remove the bracket. 36 minus 24 D and plus 4D squared is equal D squared. Then we can take D squared in this side. The equation reduced 3D squared minus 24D plus 36 equals 0. Again, we can divide this equation by 3. D squared minus 8D plus 12 is equal 0. Right? Then can take components 12 into 12. One is D minus 6. Other one is D minus 2 equals 0. Then D can take two values. D is equal 6 meter and D is equal 2 meters. All are positive values, right? Then but we have to take only one value. Then we have to discuss what is the possibilities between 6 meter or 2 meter, right? 6 meter or 2 meter, right? Then Q2 and Q1, then the charge, we considering two charges, Q2 is greater than Q1, the location must be close to the Q2. Another one is, we can see location of to right of both charges. Then E1 should be equal E2, but directions are same in this one. And then we will see It can be. What is the possible answer? If Q1 and Q2, if the 6 meter means in this line plus Q1 and plus Q2, the P can be in the answer is if D is equal 6 meter, what happened? The P is outside the one from Q2. This is the P. Because position is 6 meter. Between these two is 3. And outside 3 plus 3, 9 is larger than Q2. Then outside P. Then the answer is D is equal 6 meter, P here. Right? Then both are positive charges. Now we can check the direction. The direction. If answer is 6 meter, then positive charges, we put 1 Coulomb charge here. Then direction is Q1 to Q2. And there are, between these two, there is a repulsion force. Direction is repulsion in E1. And also we consider Q1. Q1 also positive charge and positive charge. So there is a repulsion force between P point charge and Q1 also in this direction. But the D is equal to 2 meter. Then what happened? D is equal to 2 meter means between Q1 and Q2, P is here, 2 meter, and other one is 1 meter. Because distance between Q1 and Q2 is 3 meter. If answer is 2 meter, then we can take P at that point. Then considering the directions of the charges, then what happened? Q3 and Q, E1 in this direction and E2 is this direction. In our discussion, we found electric field 0 point, right? What is the position? What is the spot? Electric field 0. But here, E1 and E2 are both in the same direction. So, total electric field is equal E1 plus E2. This is never become as the 0 value. But in this one, if D is equal to 2 meter, then E1 minus E2 is the value, then E1 can be equal E2. Then electric field can be equal 0, right? So this answer is not applicable because then we can discuss is E1 and E2 in same direction, right? Then E1 and E2 in the same direction of both charges, but direction should be same in this case. So answer is D equal 2 meter. Position P is located at 2 meter from Q1 to direction Q, right? Then we can find the D where the electric field 0. Where the electric field 0, then we can find, right? In our discussion, this cannot be happen. And that situation, this is not be equal to 0. E1 not be equal E2 at that point, right? This is the answer. Okay. The questions can come in the electric field and also electric potential. So that's the electric potential. Right. Yeah. We discuss this question. Electric field F equal QO, and other one electric field due to the point charge KQ over R squared, and we can add superposition principle, right? And this we discuss the electric potential. Other one is the electric potential. I think you remember some equation you should remember, delta V. And we can find the potential energy, conservative potential energy. Delta U is equal minus delta W, and related equations, right? Delta V is equal electric potential. It is the scalar field. Then we define delta V by delta U over Q, right? And potential charges. And same as the electric field intensity, we can consider electric field. Define the work done per unit positive charge to move the charge from infinity to the point of interest at the point P. At the point P, we can introduce potential energy Vp as Q over 4 pi epsilon naught Rp, right? Then 1 over 4 pi epsilon naught, we can take K, right? KQ over Rp. KQ over Rp is the equation related to the electric potential, KQ over Rp. Then in the superposition principle also can apply to the electric potential. We can add summation. We can take the summation of the electric field 1 over 4 pi epsilon naught as the K, Q over R. Then we can add both. If there is the 1 point charge and 2 point charge, we can find the total electric potential energy due to the particles, right? Then we can add K times Qi over R as the electric field intensity. The superposition principle can apply. In the equipotential surface in the electric field, it means then we can take same potential. We can see that the position Q and P, VQ equal Vp means W. No any work we have to done between the equipotential surfaces. Delta WQ is equal 0, right? And other equation, E is equal delta V over D, V by D. Delta V means potential difference. Potential difference is delta V. Delta V by D is the equation we can find here, right? Then these are the summary of the concept. E is equal F over Q. We already studied. And electric potential change can take delta U over Q. And delta U of the electric charge, it is equal delta W, means work. The potential energy is related to work, and it is depends only starting at end point. Delta U, potential energy is equal minus delta W, work done by. And other one is delta U is equal delta V, potential difference is equal delta U over Q, right? And other equation, the electric field is minus, because the gradient of the electric field E is equal delta V over delta X. The equipotential lines are line of constant potential. Then delta V along the equipotential line is equal 0, right? So, capacitor no, you not have. I will give one questions related with the potential energy. Last day also we discussed about this type of question, but again I will discuss another one, but same theory. 3-point charges are placed point charges are placed along x-axis as shown in below. Right? Then you can remember the questions about the electric potential. Here Q1, this is equal plus 2 microcoulomb, and Q3 is equal minus 3 microcoulomb, right? Different questions. And other one, Q3, Q2, this is the Q2, and Q3, it is equal plus 4 microcoulomb, right? Distance between them here, I'm taking this as the x equal 0 along the x-axis. This is x equal minus 2. Because then left hand right is the minus negative charges, but distance between these two is 2. Another one is x equal 3 meter. X equal 3 meter. Question is calculate the total potential energy. Total potential energy of the system. Calculate the total potential energy of the system, right? Then we can take, then what is the equation behind with the potential energy? It is equal, V is equal, if there are two charges in the system, K, Q1, Q2 over R. What R is square? K, Q1, Q2 over R is the charge, potential energy, right? Due to the Q1, Q2, we can find the charge Q1 and Q2. Now, there is three charges in the system. Along the x-axis, there is three charges, 2, -3, and 4, right? Then what is this? Three pairs we have to consider. Three pairs we have to consider in this diagram. According to this diagram, three pairs we have to consider, right? One and two and three, and also 1 and 3, right? Then you can find then Q is at 2 into 10 minus 6 coulomb at x equal 2 meter. Then I'm taking this is 1, 2, 3. Then R1, 2. Distance between 1 and 2. This is equal to meter. Alright. Then other one R2, 3. R2, 3. Distance between 2 and 3 is equal 3 meter. Right? And R1, 3. Other pair is, then you should aware about this. We have to consider 1 and 3 also. Then R1, 3 is equal 5 meter. Distance between first and third charge. R1, 2 is 5 meter, right? Then we can find the potential energy due to these three pairs, right? I'm taking potential energy due 1, 2. Due to 1, 2, we can find K times 1, 2. K times Q1, Q2 over R is squared. Potential energy is equal K times Q1, Q2 over R is squared. Right? Then K times, what is the Q1? After that, we can substitute Q1, Q2 over R12. Another one, UR3, 2, 3. Due to 2 and 3, we can find K, Q1, Q2, Q3 over R2, 3. Then another one, U1, 3. Between 1 and 3, K, Q1, Q3 should be divided by R1, 3. Right? Then we can add all together to find the potential energy of the system. Right? We can add all together. U is equal U1, 2, U2, 3 and U1, 3. Then we can substitute the values, right? U is equal, I am taking K out of the bracket. U1, 2, 2 times 10, negative 6 into minus 3 into 10, 6. Then we have to consider the sign of the chart because minus means the potential energy is minus means then can easily take can attraction them. W can easily. Other one is divided by 2 distance and other charge is 2 and 3. Between 1 and 3, 1 and 3 we can write 2 into 10 minus 6 into 4 into 10 minus 6. This should be divided by 5, not 5 squared, 5. And other one is 1 and 3, also minus sign, minus 10 minus 6 into 2 into 4, yes, 4 into 10, negative 6 and divide by distance is 3. Then we can add all together. You can consider sign. Sign should be made, right? Then potential energy 9 into 10, 9. We can substitute for the K. K is 9 into 10, 9. This one minus 3. Then 2 cancel out. Minus 3 into minus 12. 10 minus 2. This is negative value. And the other one plus 2, 8 divided by 5 means 2. No? $20. 1.6, right? 1.6, 10 minus 12. And plus 3 cancel out. Again minus 4 into 10, 12. 4 into 10, 12, right? So we can calculate the answer 9 into 10, 9. The potential energy is negative. Then we can subtract from the answer. What is the answer then? 7 plus 1.6. 5.4, right? Minus 5.4 into 10 minus 2. Potential energy is minus value. U total minus 48.6 into 10 minus 3. U. Then you can check the answer, right? If my answer, then you can check it. U total can find 48.6 into minus value, right? Then according to the superposition theory, we can find the total potential value. If they are given 3 particles, you should know there is there are three pairs. We have to consider three pairs of the charges, right? Okay. In the electricity part, then you can count the questions related with the electric potential and electric field, right? Then capacitance. Then you can follow up, but I'm not giving the questions. Other one is electric current, electricity and Ohm's law. Current, electricity and Ohm's law. The questions can come. Ohm's law is very easy. Then we know about the conductors, semiconductors we discussed. And I want to remember this. Then electric current. We can define I is equal Q over T. I is equal Q over T. Charge divided by time. Another one is the Ohm's law. The current passing through the conductor, it is directly proportional to the potential difference between two ends. And the equation is coming, Ohm's law is coming as V is equal IR. V is equal IR, right? Then we can take, this is the Ohm's law. V is equal IR. We can find the equations. Then other one is, last day we discussed about the resistor in series. The resistor in series, equivalent resistance. We can find the series means the current flowing through this part is common. Current is common. In the series circuit, then we can find the resistance. Resultant one, R1 plus R2 plus R3. Right? Then we can the our resistance R1, R2, R3 by one resistor. Taking the resultant value, we can replace the resistance by R1 plus R2 plus R3. Another one is, if the circuit is in the parallel circuit diagram, then we can find resultant R 1 over R1 plus 1 over R2 plus 1 over R3. Right? The simple circuit diagram we discussed. And I think this question I discussed in the class. Find the equivalent resistance for the two resistors in figure R1 and R2. Then you can see R1 and R2 is commonly set with the one battery. Plus and minus agrees, you can see. Then this is arrangement, represent the parallel circuit diagram, parallel combination. So we can find 1 over R plus 1 over R2 is the resultant resistance of the system, right? And the power is the question is asking what is the power generated here. Then we can find the equation P is equal VIO. P is equal I squared R O, P is V squared R. Other thing is, then sometimes this is difficult. Then Kirchhoff's law. What is the first law? First law is saying that the algebraic sum of the current entering any junction point in the circuit is 0. Then entering things is 0. Then we can find I1, A, B, C, D are entering and other one out of the junction. So in the first diagram, A plus B plus D plus C is equal E plus A, right? I think you remember. Another one is the second law. Then we can say algebraic sum of the EMF in the closed loop. In the circuit, it is equal sigma E is equal sigma IR. In IR also the V, potential difference, and E is the potential difference Then second law also we can express the algebraic sum of the potential difference along the closed loop around the closed loop is equal 0. Also we can take like the sum of the potential difference around the closed loop is 0. This is easy to remember than this one. Sum of the potential difference around the closed loop is 0. Then V A plus VB plus, then things should be equal 0 around the closed loop. Right? Then taking these two theories, one is Kirchhoff law and other one is second law, then we can find the value of the circuit diagrams. And here also circuit diagram rule 1 is due to the conservation of charge. You can see I1 is entering the point, but I2 and I3 are going out of the point. So what is the first rule? The sum of the potential difference around any closed loop is 0. Then I1 is entering, the second one, the current flowing into the point of junction is the same as the current flowing out of way from the point of junction. Then one is entering, I1 is entering, others are out, then others are away from the point junction. So we can write the first equation, I1 is equal I2 plus I3, right? Then second one is, I mentioned it is in the first one, the sum of the directed, the direction is important. Directed potential difference around any closed loop is 0. Around any closed loop is 0. Then you can see epsilon is the value of this circuit and IR is the value of the voltage of the SIS1. Then we are taking the direction in the one closed loop. If we are taking this plus and minus direction, this is the, if we taking positive value and other one is negative, then IR B equals 0. Right? This is the Kirchhoff's second law, right? I will discuss one question related with the Kirchhoff law. Last day also discussed, but I want to more discuss about it. I'm taking one circuit diagram, two batteries. So we cannot apply ohms. And symbol of the resistance is like this. Resistance R1, another resistance here R2, and other one is R3. And our second battery is here. R2 and R3, right? Then want to find the value of I2. Then current flowing through R2. Question is, what is the current flowing through R2, right? I'm taking the loop as A, B, C, D, E, F. Then I'm marking all the necessary things here, but taking direction, considering directions, right? In this one, we know this is the positive terminal of the battery, and this is the negative terminal of the battery. And also in the other side, positive and negative terminals we know. So we can consider potential between difference thing is positive to negative, right? Negative terminals, right? Then I'm taking E1 is this direction and also E2 in this direction. And taking the current. Current is passing positive axis, then I1. If this is I1 current is connected, then I'm taking this also positive and this also negative. And I'm thinking that I2 also passing through this branch, I2. So we know that this is the positive axis and this is the negative axis. And Other one is I3, current flowing through this branch. Then we can consider current is moving in this direction. This is positive terminal and this is the negative terminal. Then you should mark all positive and negative things. It is better for the calculation, right? Let us consider loop in the same direction and same direction, A, B, C. And we can consider point C. C point can apply Kirchhoff's first law. Entering current should be 0. Entering current should be 0. Then you consider point C. I1 is entering, I2 also entering, and I3 also entering. Then I can write the equation I1 plus I2 plus I3. This should be equal 0. Then consider point C. We can write like this. And VR1, the potential difference is if the current is flowing through I1, we know V1 should be equal I1 R1 according to the Ohm's law. And same thing, VR2, potential difference R2 is I2 R2. And V3, potential between I3 R, right? Then we can apply Ohm's law. Then I'm writing 3 equations. Then after that you can follow up. I won't write the equation only. Then I'm considering ABCF loop. ABCF A loop. Direction is take same direction, right? Starting A, B, C, F, again A. Then we can write the equation ABCF A. Then what happened? E1 is negative value because I am taking this direction. And I consider positive to negative is the positive one. Then E1 is negative value minus E1. Then other one, same directions. Current is passing positive to negative, same direction, plus I1 R1. And also this is, then you can see current is passing upward. I'm taking downward direction. So minus I2 R2. Then we can rearrange this equation. E1 in the other side plus I2 R2 equal I1 R1. This is our equation 2. First one is this one and second one is this. And also, then now we can consider the second loop. F, C, D, E, again F. Right? Then we can write, consider I2. Then here, I2 R2 is positive because direction is same. Current flowing through this direction. Then I2 R2 is positive value. But other one is negative. I3 R3 and minus E2. This is equal 0 in the second one. Second one. Right? Then again we can rearrange the equation. E2 plus I3 R3. This is equal I2 R2. Then we have 3 equations. 3 simultaneous equation. You can find the value for I2O, I3 and I1 we can find, right? Then you should remember, please put positive and negative terminals. Marks all the positive and negative terminals. Then it is easy to handle, right? Then first equation is entering current equals 0. Another one, Kirchhoff's second law, all potential energies around the closed loop should be equal 0, right? Then consider battery and consider resistance and we can substitute value. Then according to the direction, it can be changing minus sign, right? So you should remember this equation about the Kirchhoff's law, right? Then electricity part is finished. The question can come potential law, electric field law, Ohm's law, or Kirchhoff's law, right? Then other one, easy one, then waves. I will go through quickly. about the waves. Yes, the heat waves. Waves and energy. This is also easy. Then you have to remember the equations, transverse and longitudinal waves, and what is the period of the wave. Then if equal 1 to 2. And then if they are giving the graph, then you have to understand what is the lambda amplitude A, and equation V is equal F lambda. Then we can find using the graph. Sometimes we can find the lambda value. And same graph can give position versus amplitude. And same graph can give a time versus amplitude. The time versus amplitude, amplitude versus time. Then on the hand side, amplitude versus time, and other one, amplitude versus position. This is represented, amplitude is y and position. Then what is the lambda? Lambda is between two crest or top. And we call this as wavelength, symbol wavelength lambda. And if we know in the previous graph, then sometimes this can be due y versus time. Then what is the time period? Time period is for one oscillation. Time per one oscillation, right? Then we can find capital T by using the graphs, right? Then equation is, if we know lambda and T, then we can find speed of the traveling wave. V is equal F lambda equation. Then this is the one graph showing here. Figure shows the yt versus time. Then what is the lambda? What is the t? Then questions can ask. What is the period of the wave? Then axis is time. Time axis, what is the wave? And what is the wavelength and amplitude? Then question can ask, right? Lambda we can find, then this is mentioned in the x direction, straight at speed 5 meter per second. The figure shows the graph of yt for point x equals 0. Transverse harmonic wave travels in the x direction at the speed of 5 ms minus 1. The figure shows the y versus position, x equals 0 position. Then at this graph, we can find what is the period of the wave. This is time. Then what is the period? Time for one revolution. And wavelength. Wavelength can find the using the equation. It is mentioned that speed is equal 5. Speed is, then we know if we can find the equation lambda is equal v, right? And lambda is equal, the equation means here lambda is v is equal f lambda. F means frequency. Frequency is equal 1 over t. So v is equal f lambda. And the same graph, time versus y, and but mention the straight at the speed is 5. It's minus 1. So we can find the period and then wavelength. Lambda is equal et. Velocity versus time et. And amplitude. Amplitude is the maximum height in the y-axis. The maximum height is 0.003. Then you can write the answers asking in the graphical representation. Then principle of superposition, we can the minimum and maximum value in the overlapping. And reflection wave, I think you remember. Then other one is if the wave speed change at the boundary. The wavelength of the transmitted wave is not same as the wavelength of the incident wave, but frequency is same. V is equal F lambda, frequencies are same. So we can find frequency in the medium 1, V1 over lambda 1. The frequency of the medium 2 is V2 over lambda 2, but these two should be equal. Then you should remember frequency is not changing. If the boundaries and wave is transmitted wave and incident and reflected wave, we can see the but frequency is not changing through the medium. Velocity and lambda can be changed. Then V is equal F lambda is the constant, or F is equal V1 lambda 1, V2 lambda 2. F is constant, right? Yes, then these are the things. Then questions can come asking the given graph and sometimes given data, what is the omega, right? Angular frequency and frequency can ask, right? Another in the optics was Snell's law, the reflection of light. This process where the light is prick the surface and bounce back, unable to see the particles. Then you can see this is the angle of incident and angle of reflections. And it's Snell's law behind the reflection of the wave, n1 sine theta 1 is equal into sine theta. Then we can find n is refractive index, n1 refractive index in medium 1, and n2 is refractive index in medium 2. Combine these two equations, we can find refractive index of one medium. Then one question is given. What's the theta or do something? You can ask. Then you should remember about the Snell's law. Right? Snell's law, we have to remember that. How light refracts when passing from one medium to another with the reflection index. Right? Then you should remember that parts only. Okay, then what is the other one? Mechanics, no? Others behind this Newton's law and things. Modern physics, okay. Electricity, questions can come. Waves, one question can come. In the electricity, electric field and voltage, and other one, Kirchhoff's law and Ohm's law can come together, right? You can select 3 questions out of 4 questions. And then we will discuss some mechanics problem, the small questions. Then we can remember. Okay. Small questions, then kinematic equation. Questions can ask the kinematic equation. Right. Related with the kinematic. Small questions we will discuss. We want to remember memorize the theory. During a training run, an athlete accelerates uniformly like 1.4 meter seconds from rest for 10 seconds. Time is 10 seconds. Then continues at a constant velocity. A constant velocity. So, further 20 seconds. For a further 20 seconds. Then after 10 seconds, they gain some velocity. Then with this velocity, the constant velocity, further runs within 20 seconds. The question is what distance? What distance does the athlete cover over the first 30 seconds? See, easy questions, but theory behind this of the run. Kinematic equation, right? Then in this question, I can memorize about the kinematic equations, right? So we want to find total distance run by. Then we know there are three kinematic equations. V squared equal U squared plus 2AS. Other one V is equal U plus AT and S equal UT plus half AT squared. You remember. What is the V? V is the final velocity and U is the initial velocity. A is the acceleration. S is the total displacement, right? And if we know time, acceleration, velocity, can find the final velocity and starting velocity and time, acceleration, then we can find total displacement, right? Then whatever the equations we can use here, then according to the data we have, right? In the for the first 10 seconds, then athlete is a guide, uniform acceleration is 1.4 and initially starting from rest and 10 seconds. Then after the 10 seconds, some velocity get is at reach to some velocity, then continue with they are according in the constant velocity for further 20 seconds. The question is asking what is the total distance, right? The first one is moving with constant acceleration and second one is moving with constant velocity. Next 20 seconds, right? Then we can find S1 and S2. I'm taking as S1 and S2 the total run. And initially, U is equal 0 and A is equal 1.4, MS minus 1 and T is equal 10 seconds. What is the S1? Right? Then the equation related with this, we can take S1 is equal UT plus half AT square. S1 is equal U is equal 0 and half. A is 1.4 and T squared is 10 into 10. Right? The S1 can be found by 70 meters. During other part is moving with constant velocity, but we have to find the velocity after the 10 seconds, right? Then the final velocity we can find after 10 seconds. Then what is the equation we can put? We want to find the V, right? This is case one. You can remember that. Then we have to find the after the 10 seconds. What is the V? Then we can put the equation. V is equal U plus AT. Final velocity is equal initially at rest and acceleration is 1.4 into 10. This is equal 14 meter per second, the final velocity. Then now, this is happening with constant velocity. 14 ms1 within another 20 seconds. So S1 is 70 meters, then S2 is equal. Also, we can put this equation ut plus half at squared, but there is no any acceleration. So S2 is equal ut, right? Other part is 0. Then S2 is equal. What is the velocity? Gain from him, then 40 into 20. So S2 is equal 280 meters. Now total distance covered by the S1 plus S2, it is equal 350, right? 350 meters. Then we can apply kinematic equation. Then you should remember about the kinematic equations, right? Then momentum and collisions and Newton's second law questions can come, right? And projectile motions also can take the questions, one questions. Anything you have to raise, then remember. Let me.
No, madam, up to here, it's clear.
Right. Okay. Then the question paper consists of 3 questions, right?
Okay, madam.
Then we can so then electricity and potential. It is some questions here. Then Ohm's law and things. Then I'm giving 4 or 3 questions related with one theories. Then you can answer 3 questions. 20
Okay, madam.
and 60 for the final paper. Okay. If no any doubts or questions, I can conclude the session, right? And when is your
Madam,
exam? Until 6, no?
madam, I didn't get you.
When is your final exam?
Madam, on 7th of June.
Okay, okay. Right. If not any questions, I will wind up the session. And good luck
Madam,
for your final exam.
okay,
Yeah?
do we have to fill the attendance sheet today also?
Yes. Chat box. Wait. Right now you can fill it.
Okay, madam.
Follow the recording because I discussed, I think 5 questions related with the modern physics part, right? They are easy.
Okay, madam.
Only you have to remember the equations, right?
Yes, madam. Those one easy.
Ah,
Kirchhoff law and the Ohm's law also can manage, need madam.
yes. Then others, modern physics part, I think you can manage, no?
Yes, madam. Those one also possible. And Newton laws and mechanics part also possible somehow.
Yeah.
The equations. Only we have to remember equations, no?
Yes.
Snell law and the
And
things also.
electric field,
Electric field better, but only I have bit doubt with the magnetic fields once.
I know I'm not giving the questions related with the magnet.
Okay, madam.
Have you done fill the attendance? Below the name.
Madam, at the last moment, Ami.
Okay.
Okay, madam, done.
Okay. Thank you.
Thank you,
Good luck
madam.
for your final exam, right?
Thank you, madam.
Okay.